The James Webb Telescope isn't just discovering new stars and galaxies. It's finding things that, according to our theories, maybe shouldn't be there. In the first blush of cosmic dawn, a time incredibly close to the Big Bang, Webb is imaging huge, well-formed galaxies that our scientific models just can't explain. It's like finding a fully built skyscraper in a photograph from the Stone Age. These aren't small details we got wrong. These are profound contradictions that are forcing scientists to rethink the very basics of how our universe grew up. The discoveries are coming so fast that astronomers are openly saying we need to tear out entire chapters of our textbooks and start over. What we pictured as a slow, predictable story of cosmic growth is turning out to be far more chaotic, rapid, and endlessly more fascinating. And the puzzle of these impossible galaxies is just the beginning. The impossible early galaxies. For decades, we've relied on a clear, elegant idea of how the universe evolved, known as the lambda C. It's the standard model of cosmology, and it predicts that the very first galaxies should have been small, messy, and disorganized. They were like tiny seeds that, over billions of years of slow and steady mergers, would eventually grow into the grand, spiral cities of stars like our own Milky Way. Light takes time to travel, so looking at the most distant objects means looking back into the past. Webb's powerful infrared vision was specifically engineered to cut through the ancient cosmic fog and see the light from the universe's dawn. And boy, did it see it. What they found was a lineup of cosmic rule breakers. Take a galaxy like JWST 1420, so far away that we're re-seeing it as it was just 290 million years after the Big Bang. In cosmic terms, oxygen is a metal, an element heavier than hydrogen and helium. These heavier elements are only forged in the nuclear furnaces of massive stars and get scattered into space. When those stars die in fiery supernova explosions, and too full of heavy elements to exist so early in time, some even appear as well-ordered disks, a shape that was thought to take at least 6 billion years to form. These discoveries don't mean the Big Bang is wrong, but they do suggest our understanding of what happened after is deeply flawed. The story of how galaxies came to be isn't a slow, steady construction project. It's more like a series of furious, explosive building booms. The universe, it seems, was in a much bigger hurry than we ever thought. The textbooks aren't just being updated, they're being challenged at a fundamental level. To find oxygen this early means that not just one, but multiple generations of massive stars had to have already lived, died, and seeded their surroundings with new elements. This entire cycle had to play out in a cosmic blink of an eye. The galaxy wasn't just big, it was chemically grown up, way more developed than it had any right to be. According to our models, a galaxy this young should be a toddler, barely able to hold itself together. Instead, JWST 1420 is astonishingly large and bright, weighing in at several hundred million times the mass of our Sun. The question that immediately floored scientists was, how did nature build a galaxy so bright and massive in less than 300 million years? According to the standard model, there just wasn't enough time for that to happen. But what it found sent shockwaves through the astronomy community. The timeline was immense, the process was gradual, and it all made sense. Then, the James Webb Space Telescope opened its golden eyes, and that tidy picture was shattered. JWST was built to be a time machine. In a program called the JWST Advanced Deep Extragalactic Survey, astronomers pointed the telescope at a tiny patch of sky and just stared, letting the incredibly faint, ancient light pile up. And it wasn't just its size. When astronomers looked closely at the light from this galaxy, they found another shocker: the unmistakable signature of oxygen. This wasn't a one-off. Webb keeps finding these so-called universe breakers, galaxies that are too big, too bright, too structured, whispers of life on a distant world. One of the deepest questions we've ever asked is, are we alone? For most of human history, the answer has been pure speculation. But the James Webb Space Telescope is turning that philosophical question into a real, observational science. It's a chemical detective that can sniff out the makeup of atmospheres on planets light years away, hunting for the chemical signs of life, and on a planet 120 light-years from here. In the constellation Leo, it might have found one of the most exciting clues yet. As the starlight filtered through the planet's atmosphere, molecules within it absorb specific colors of light, leaving a chemical fingerprint for Webb to read. This is called transmission spectroscopy. The first look confirmed the High world theory, but it also held a faint, tantalizing hint of something else, something so unexpected it demanded a second, harder look. The research team itself has been the first to urge caution, stressing that more data is needed to be sure the signal is real and not just a fluke of the instrument or some unknown chemical reaction. But even with that healthy dose of skepticism, the hint of DMs on K218b is a revolutionary moment. It's the first time we've plausibly detected a potential sign of life that, on our planet, is so tightly linked to living things. We're no longer just wondering if we can find signs of life. We're actively doing it. We are analyzing the air of other worlds. And whether or not this specific clue pans out, it proves we finally have the tools to start answering the question. The planet is named K218b. It's what we call us, about 8 times the mass of Earth. Now, DMs might not sound very exciting, but here on Earth, it's almost exclusively produced by life. Specifically, it's churned out in huge amounts by ocean. It's the chemical that gives us that distinct smell of the sea. To find even a hint of it in the air of a distant ocean-covered world is one of the most powerful signs of biosignature we could ever hope to find. And it orbits its star right in the sweet spot, the habitable zone, where temperatures could be just right for liquid water. Previous observations had already found methane and carbon dioxide there, leading scientists to think K218b could be a Hyceon world, hypothetical type of planet with a deep water ocean under a hydrogen-rich atmosphere. These worlds are prime suspects in the search for life. Using its incredible precision, JWST watched K218b as it passed in front of its star. That second look delivered a potential bombshell. The data showed evidence for a molecule called dimethyl sulfide, or DMs. Now, let's be crystal clear. This is not a confirmed detection of alien life. The search for life out there is one of the most thrilling adventures in all of science. With every new observation, the James Webb Telescope is getting us closer to an answer. If you find this cosmic journey as amazing as we do, and you want to stay on top of the latest discoveries, make sure you subscribe and ring that notification bell. You won't want to miss what Webb finds next. The birth of a monster black hole. At the heart of almost every big galaxy, including our own, there's a monster, a supermassive black hole, weighing millions or even billions of times more than our sun. For a long time, their existence in the early universe has been a huge headache for cosmology. We see them powering brilliant quasars when the cosmos was less than 1 billion years old, but our standard ideas about how black holes grow just can't make the math work. The traditional theory is that black holes grow slowly. A massive star dies, collapses into a stellar mass black hole, and then spends eons gradually sipping on gas and merging with other black holes. It's a slow, steady process. But to get a black hole to 1 billion solar masses, this way would take way longer than the age of the early universe. It's a timing problem. So how did these ancient monsters get so big, so fast? The idea is that the violent galactic collision squeezed a massive cloud of gas so intensely that it triggered this rare and extreme collapse, birthing the massive black hole on the spot. Like other groundbreaking finds, the evidence is still being debated but if this is confirmed, it would be our first direct look at this long-theorized way of making black holes, solving a decades-old cosmic paradox. It would be a literal snapshot of the birth of one of the universe's primordial giants. Scientists have a wilder theory, a direct collapse black hole. In this scenario, you skip the star phase altogether. Instead, under just the right extreme conditions, a gigantic primordial cloud of gas collapses catastrophically under its own weight, not into a cluster of stars, but straight into a massive black hole. See, already tens of thousands of times the mass of the sun. This would give these black holes a huge head start, letting them grow to supermassive scales in time. It's a neat theory that solves a big problem, but for years, we had zero direct evidence it actually happened. Until, possibly, now. While sifting through Webb's data, astronomers spotted a truly weird object. They've nicknamed the Infinity Galaxy, the result of a spectacular head-on crash between 2 spiral galaxies. But the real shocker isn't the collision, but what's sitting in the chaotic, gas-filled space between the 2 galactic centers. There, Webb and the Chandra X-ray Observatory found a black hole clocking in at around 1 million. The team that found it was stunned. The black hole wasn't in either galaxy's core, but in the no-man's land between them. The team proposes that they've caught a direct collapse black hole in the act of being born, rewriting the story of our own backyard. While Webb often stares at the edge of time, some of its most mind-blowing discoveries are happening much closer to home, showing us that even our own Milky Way galaxy is stranger than we ever imagined. It's changing how we see the birth and death of stars, and the creation of new worlds. For years, astronomers have studied Cassiopeia, the glowing remnant of a massive star that blew up about 340 years ago from our point of view. In older images, it looked like a hazy, expanding cloud. But when Webb aimed its infrared eyes at it, a breathtakingly detailed new picture appeared. The space isn't empty. It's filled with complex knots and tendrils of gas and dust. Most startling was a huge, looping structure of green light near the remnant center, which scientists quickly nicknamed the Green Monster. First, let's talk about death. By combining Webb's data with X-rays from the Chandra Observatory, scientists solved the mystery. It's like finding a lawnmower sitting in a freshly cut path through tall grass. The planet's gravity is actively carving out its own orbit, sculpting the very system where it's being born. We aren't just seeing a new planet. We are watching a solar system assemble itself. These discoveries in our own galactic backyard are just as profound as those from the edge of the universe. They show us the cosmic life cycle in stunning, unprecedented detail, from the explosive death of one star to the quiet formation of a new world around another. The Green Monster isn't actually part of the material thrown out by the star. It's created by the supernova's supersonic blast, waves slamming into the surrounding gas. For the first time, we're re-seeing a true 3D map of how a dying star's guts are recycled back into the cosmos, seeding it with the heavy elements needed for new stars, new planets, and maybe even life. From the death of an old star, we turn to the birth of a new world. Taking a direct picture of an exoplanet is incredibly hard. They're unbelievably faint and completely lost in the blinding glare of their parent stars. But Webb has a secret weapon called a coronagrapher, tiny mass that can block out the starlight, creating an artificial eclipse right inside the telescope. This lets Webb spot the faint, warm glow of a planet right next to its star. Recently, astronomers used this trick to make a major first for the telescope, the direct discovery of a brand new The world is called TWIA 7b, a planet about the mass of Saturn, orbiting a very young star just over 100 light-years away. What is so cool about this is that TWA 7b is the lightest exoplanet ever to be directly imaged, proving Webb can find smaller worlds than ever before. But there's more. The planet was found sitting perfectly in a gap in its star's dusty, planet-forming disk. What we're witnessing with the James Webb Space Telescope is a genuine revolution in how we see the universe. The cosmos it's showing us is not the one we expected. The Webb era has just begun. With every new image and every new spectrum of light, we are peeling back another layer of reality. The telescope isn't just answering old questions. It's throwing a whole new set of mysteries at us. It's forcing us to admit that we are just beginning to understand our place in this vast, strange, and magnificent universe. And the greatest discoveries are almost certainly still to come. It's a universe that builds galaxies faster, bigger, and with more structure than our models allowed. A universe where a distant, water-covered world might be exhaling gases tied to life. A universe where we can watch the cataclysmic birth of a monster black hole. And a universe where even our own galactic neighborhood is filled with wonders we never knew existed. From the ghostly green monsters of dead stars to the delicate dance of a planet building its own solar system. These discoveries are all connected. They are weaving together a new picture of a cosmos that is more dynamic, more chaotic, and far more surprising than we ever imagined. What an incredible ride. If you enjoyed this deep dive into the cosmos, and want to be the first to know about the next shocking discoveries from the James Webb Telescope, don't forget to like this video, subscribe to the channel, and ring that notification bell. Join us as we continue to explore the final frontier. Thanks for watching.